will be looking into load combinations. The last class we have discussed what are the loads which is acting in a structure and different code books which are required for assuming the load. Today's title will be load combination and how we can take the combination of load and what are the guidelines which is given by the code. The last class we have discussed 5 types of load. They are, first one is dead load, then imposed load. So live load comes under imposed load. In imposed load you might have snow loads, etc. Then you will be having wind load separately, earthquake load and other loads will be there. If you are designing for all the case of load, what will happen? The loads will be much higher. The stresses which will be acting in a structure will be much higher. Okay. Take an example that if you are designing a simply supported beam, apply only the dead load. Take an example that you have only the self weight of the beam. The deflection will be very much small, but if you add live load to that beam, what happens? Then according to your live load, the beam might deflect. See, in your classroom, it has been occupied by around 60 number of students. What will happen? The load get increased, this beam will be subjected to deflection. So you will be having a much higher deflection. Before 6 or 7 hours, this much of load is not there in the building, yes or no? So within a specific period of time, all the people are occupying here and this creates a load. When all the people are evacuating the structure will not deflect that much. So you cannot visibly see that. Even though some people might be in the higher floors, if this much of occupancy is there, the deflection will be very small. Why it has been not visible? In the sense they are designing as per the limit state. So the limit state code says that you should not have the deflection limit, that is 10 mm. Take an example of 10 mm deflection is not allowed for any structure. In the sense, so what is 10 mm, which is 1 centimeter, which is nearly very small. So you cannot observe in your visual eyes that 1 centimeter of deflection which is there in the beam or not. So if you are occupying 60% or you can occupy 100 number of percent, definitely the beam will slightly bend and it starts deflecting. The moment keep on increasing. So you might not observe that. Then what happens? You need higher depth of material. Okay. Now you consider the wind is acting to your structure. So you blow the wind and the wind is acting to your structure. Finally what happens? Your load becomes much higher and the stresses will be higher, so that the material dimensions will be higher. Yes or no? Everything is proportional. So if you are keep on adding all the loads, what will happen? Finally you will end up in a higher stress of the material, and one thing, safety will be gained by you, but the reality and probability will be missed by you. Even the Indian Standard Codes 1893, which gives that earthquake occurs not frequently. Daily you will be not finding any earthquake in your place. Earthquake will be occurring only in a 20 to 30 year of span once. Yes or no? So it is not a frequent event. Yesterday during the earthquake we were traveling there. Today there will be an earthquake, so we will be crossing that. So like that it could not happen. So earthquake is a rare phenomena. If you are considering the earthquake, and there should be a probability. So whenever you are considering multiple number of loads, the load will get increased, the stress will get increased. Finally you will get safety, but you will not get economic design. If some people are desiring to build their house, you can keep on increase the safety. What happens? Finally they will end up the 15 lakh project in 30 lakhs. So you have to spend twice in order to get that safety. So you can say that your structure or your building is very safe under wind, earthquake and accidental loads. You can say that, but the cost is 30 lakhs. So you can say that this is a quotation for only dead load, wind load and the imposed load. So your quotation is 20 lakhs. When I am giving you a design, I will only consider imposed load and dead load only, and I will give the design. This design and the project cost will be 15 lakhs. Imagine if you are a client, which option you will choose? Either 15 lakh, 20 lakh or 30 lakh. So we are saying that 100% safety, nothing will happen. Even for a small product in Amazon, if you are purchasing, you know that the built-in quality product are higher in price. You very well know that. But the cheapest price will be having attraction. It will attract you automatically. So which range you will go? That depends on the client. Even though you might be a designer, you have to give options for your client. See, I will be designing the building for only these two forces, and if wind has to be taken or if earthquake has to be taken, that depends on the person who is building. See, if you are a king, if you are building your building or a structure, you should take utmost care and you should consider all the loads. So that is why all the monuments in each and every state are standing still for more than 100 and more than centuries, more than 1000 years. Why they are standing? In the sense, they consider all the loads, they consider the safety as the utmost priority, hence they are getting the efficiency. In the load combination, code gives a guideline that, okay, don't go for highest safety, which will be most costly, and do not cross the minimum limit. So the guideline gives that don't go beyond this limit and purchase. Don't go beyond this limit and make your specification. That is why these load combinations are given here. If you consider dead load and imposed load, so you can consider by this is case A, and you can start your design only by making dead load and imposed load. What are the imposed load? It can be live load, it can be snow load, it can be rain, all the things you can consider and give your design. Or else you can take dead load, imposed load, wind load or earthquake. Either you have to take only one load as per the guideline. Why both should not be considered? Why the term or is given here? Have you seen any event, both earthquake and a storm acting simultaneously? Only in Hollywood films it will happen. Earthquake comes, heavy cyclone will be there, then tsunami will be there, then the aliens will come. Everything will be there at the same point of time in the same plane. So this will only happen in the movies where your imagination is too high. See, the movies are the expansion of your imagination, but it is not the reality. Whatever movie you can watch, it is the imagination of the director. He is imagining that. Here we come to reality. Reality in the sense, code gives the reality that no two natural hazard will happen simultaneously. This is a hazard. Either wind or earthquake will get simultaneous effect. After the earthquake, the tsunami can come. Not during the shaking, tsunami comes, everything will happen. No, not like that. So only one event might happen. So that is why they have given either you can consider earthquake or the wind. The C class, that is dead load plus wind or earthquake without considering the imposed load. So can you say that the bending moment due to imposed load will be higher, or the bending moment due to earthquake load will be higher? So by your reasoning power, you tell me which bending moment will be higher. When you consider earthquake force, your moment will be higher, yes or no? So that is why they have eliminated imposed load here. You consider only dead load and wind or earthquake load, then you can proceed your design. And finally, dead load and erection load. Erection load is when you are constructing your structure, you will be having the certain equipments. It might be cranes. You will be taking all the members and erecting. You have to take the erection load. Why? Because since this is a steel structure, erection loads will be there. In prefabricated structures, erection load will be there. But if you are making cast in situ concrete, there will be no erection load, which will be not higher. Okay. So you take down this table 4, which is given in IS 800. So how much you should consider is the combination of load. If you consider dead load, live load, and CL is crane load. DL is dead load, LL is live load, CL is crane load. Okay. If you are taking these three loads, the limit state of strength gives the partial load safety as 1.2, 1.5 for dead load and 1.5 and 1.05 for live loads. So you have to consider these two for live load, and crane load, whatever is exact, you can take the crane load. So what you have to do here, 1.5 times dead load and 1.5 times the live load. So this should be your limit state of strength. If you are designing for limit state of serviceability, how much you should multiply? If, say for example, if code book gives a dead load of 2, you have to multiply by what? 1.5 here. If dead load is 2, what do you have to do here? You have to multiply it by 1.5 and take the design load. So load is different and design load is different. So if the wind load is acting, last class I have given an example that the highest wind in an Bangalore region is around 36 meter per second. So if you are considering 36 meter per second, so you will be having the stress. Whenever the dead load is being taken, you have to multiply by 1.5. If live load you are considering, you have to multiply by what? 1.5 alone for designing of limit state of strength. If you are designing for limit state of serviceability, you can take the dead load as it is, that is 1 times the dead load and 1 times the live load. So here you have given the classification, you have to take this and proceed the problem. Whenever you start the problem, first step what you have to do? They will be giving the load, what you have to make? Multiply the load by what? Partial safety factor, then start the problem. So what are all the things should be done before starting a problem, which we are discussing here. Okay. Then if you consider dead load, live load, crane load plus wind or earthquake load. If you are taking like this, you can take the partial safety factor for wind force or for earthquake as 1.5. And note that they are not giving any multiplication factor for live load. So you have no values here. They are giving only importance for dead load and the earthquake load here. See, this is table 5 of IS 800. So in design of steel structure, 2 factors you have to use. First one, for whatever load it is having, you have to use the safety factor. Second thing is for material. If you are designing for resistance and governed by yielding, you have to consider the partial safety factor for material as 1.1, and if you are designing for bolt, it might be friction, bearing, you have to take 1.25. You can fabricate your bolt either in the shop or in the site. So you can do both the things. Whatever you are doing, you have to take the safety factor as 1.25. If you are doing rivet connection, take the safety factor as 1.25. And for weld, you have to take, for shop fabrication is 1.25 and field fabrication as 1.5. This is the only difference. Why? Because you have the better accuracy, you have the better implementation of the steel connection. If you are connecting 2 members and 2 sections, what happens? If you are there in a shop, you might have the better quality, you might have all the equipments which are around you. So they are giving 1.25 and 1.5 for fabrication of this material. Codes and specification. Primarily, the codes are for ensuring adequate structural safety. We cannot design as per our imagination. You should have your limit. So this limit is being given by the code book only, and the reality which will be discussed here. The aid of the designer in the design process. Without the code book, the designer could not be able to find the reality in design and the execution. Okay. Often the result of sophisticated analysis, if you have the code books, which is very much easy to make the analysis or design. So without code book, it is very tough to make the analysis. You have simple steps. See, since you are aware of analysis of determinate structure, you have number of techniques for finding bending moment and shear force. So if you come across IS 456 2000, they give simple 2 or 3 formulas. With that formula, you can find bending moment for all the practical cases. So this is being achieved only by the code books. They ensure consistency among different engineers. If you are giving your design or analysis report and other person is giving the analysis and design report, the code book ensures that either the design is good to go or below the standard. If 100 number of engineers are there in a country, they cannot give 100 solutions. So in order to ensure the uniformity, the code books are required. So if there is no code book in a country, it is very difficult to get to a solution. So according to the evolution of engineers, their practice, the code books comes into effect. If the implementation and applications are very less in a country, then limited number of code books will be there. So as an engineer, you have to strive to all the difficulty in order to make a code book. So making a code book and forming committees is developing a nation. It is not a simple task. So as an engineer, everybody has to take care of a certain aspect of engineering. See, even if you want to do a simple test, that is specific gravity of sand, specific gravity of coarse aggregate. If you want to find that, you have separate code book for that. In all the code books, the last page consists of the committee members who are all drafted the code book. So they have done the number of times this experiment. The country is being developed and the code book is being developed by this phenomena. To make a consistency, code books are essential to protect the structural engineers from disputes through codes in many cases. So this is what I said, even in any dispute on court and order law, you can defend by taking the code books. And okay, what is the need of specification? So the last slide I have discussed the code book, and in this slide specifications. As a designer, what are the specifications you have to give for a site? First thing is material that must be used in structure. If you are using multiple number of materials, you have to list it out. If you are building a house, that house is being designed by RCC structure only. You have to give in your design report that M25 grade of concrete is used. What is the steel you are using? FE 415 or FE 250, you have to indicate that. And for all the windows, you are using UPVC material, that is UPVC window or wooden window. What about the frame of the wood? What will be the quality of the wood? Either it is teak wood or a palm wood. So you have to mention that. For all the materials you are using in your design, you have to mention. If you are using stainless steel for handrails, you have to indicate that MS steel or stainless steel is used for handrails. Okay. Next thing is size of structural members. For beam, how many members are there? How many types of beams are there? You can know that from your classroom. You can observe that there are two types of beam. One is the higher depth, which is available in the lengthiest span, and another one is shorter span, which you have a less depth. How many number of columns? If you know that the column which is here is different from the column which is there in veranda, so you have to indicate these sizes of your structural member. Joint details, expected quality and tolerance. Instructions on how the construction work to be done. This is also should be given. Why? Because during any construction, you have to indicate that before laying a concrete, the member should be thoroughly made a thin plastic layer in order to prevent the stickiness between the slab or the shuttering which you are providing and the concrete which you are pouring. If you pour a concrete directly, what happens? You cannot remove the shutters. So due to that, you might apply either a grease or a separate layer in order to detach that. A designer has to give their own specification, so it has to be also indicated here. Okay, whoever can write the specification, that is the project manager can write, or architect can write, structural designer, anyone can write the specification. The structural engineer should be involved in preparing or approving all the technical content.